So good evening, everybody. It's afternoon, right? Okay, so you know our final exam date is on December 4th, right? Yes. When? Never. So you would like to pass? I sent you an announcement. Is it 3:30 or 3? Not 3 to 5:30. Maybe 3:30 to 5:30. 3:30 to 5:30. Okay. So test will be mostly about 2 hours. So longer. Okay. I'm not sure yet. If I know it, then I will share with you. But maybe at least 10 questions. Yes. Because the test will be longer. So last time we were discussing searching and sorting algorithms, right? Searching and sorting. So we discussed linear search algorithm, and then we discussed linear search, and then we discussed binary search, right? So what is the advantage and disadvantage of binary search? Can anyone please help me? What is the limitation of binary search? Yes. In order to do a binary search, your array or your list will be it must be sorted. If it is unsorted, then it will not work. Okay. That is the one, but what is the reason that the binary search needs and is sorted with the result? Because yes, in the binary search process, we always make the list half. In every iteration, we make the list half, so that process becomes faster. But the limitation is that the array needs to be sorted, because we know that the limitation of the linear search algorithm is that you may need to search all the way in, because it's called the runtime complexity. Runtime complexity is denoted as big O(n). Big O(n) means that in case you have to go all the way in of the array, then your complexity will be big O(n). That means as if your array size is bigger, you may need more searching time. So this is denoted by big O(n). That means big O, uppercase O, N. This is the complexity, time complexity of. You will learn that in your later courses. How to find out big O(n) complexity in your. Okay, then what is the time complexity of binary search algorithm? Can anyone help me? Yes. Yes, we go log n. What is the base of this log? 2. So this is for linear search. For binary search, big O log n. For binary search. Okay. So as we know that base is 2. Log n is base 2. As we know, the log of base 2 is 1024 equal to what? Log 2 to the power 10 equal to 10, right? So if your array is already sorted, you know that, right? So then there is no reason to use the linear search process, right? You can easily use binary search algorithm. The process of linear search algorithm is that we search all the way from the beginning to end, all elements we do search. Okay, but for binary search algorithm, we follow a process. For instance, if I have a list of my numbers, then this is my high point, higher index or high index, and this is my low index. And if I have my high index and then I get my low index, lower index or low index is always 0, right? And then easily I can find the middle index. So my middle index will be somewhere here. And the process is that I will find the middle index. Okay, I will calculate the middle index and I will search my expected number at that position with the middle index. If it is matching, then fine, I got it. If it matches, then fine, got it. If it does not, so for instance, if my middle, so for instance, I have my number 2, 7, 8, 9, 10, 12, 14, and 17. And if I want to search 10, so then at the first search I may get 10. If I do not get it, then what I will say, I will say my expected number, if my expected number is 8, for instance, then I will say whether 8 is less than 10 or greater than 10, right? If it is less than 10, okay, then what I will do, I will move the high from here to there. I will recalculate high, right? My high point. And then when I recalculate my high point, then I will get my new midpoint. And then I will keep that iteration. Otherwise, if I was supposed to search like for instance 14, then when I see that my expected number 14 is greater than my middle index number 10, then I will move the low index to here to mid and mid to a new position. This is the concept. Okay. So since I am changing my middle, okay, and I'm changing either or my low index or my high index, and then I'm cutting off half of the list elements, right? So this is why. So either if you go either this way or that way, every time you are making your list half. This is why it's called complexity is log-based way. So in case you have very large number, this process will be even for searching with a list of 1024 numbers, 1024 elements, you have to do only 10 iterations. So anyone has any problem in understanding binary search algorithm? In your final test, you will get one searching algorithm and one sorting algorithm, okay? We are discussing 4. So among these 4, you will get 2. I don't know which 2 you will get, okay? So today I want to discuss overall everything from the beginning. In my next class, I will bring some cup and then we can do some activity. How to do binary search algorithm, and then but that will take time. But I want to do more stuff. This is why I did not bring my cups. So if you do a Google search, if you look at this slide, okay, and if you do Google search, all of it is similar. The algorithms are almost similar, but some algorithm has a little bit variation. Yes. I'm not getting 50 this time, and then other people are getting. Tomorrow I will know how much. Because of the holidays, maybe they have started getting. I think it will take a week. No, they are never after the exam. Before exam. So you see here how we are calculating mean. It is equal to low plus high divided by 2. Since our low and high, these are what the low index and high index, these are integer numbers. So your mean index will get an integer number. Okay? So even if your low index is 0 and high index is 9, for instance, okay? So 0 plus 9 equals to 9 divided by 2, you will get 4.5, right? You will not get 4.5. You will get 4. Okay? Yes. Low plus high divided by 2. Since low means low index and high means the high index is always integer number. So when you calculate your mean or recalculate your mean, you will get what is an integer number, not a fractional or decimal number. Okay? So do not be confused that you will get a lower number or decimal number. No. Your index will be always an integer number, whole number. So I've added some extra slides here in order to discuss binary search algorithm. So you can look at this. Okay. And then in the last class we started sorting, right? Sorting is the process of rearranging your elements, either in ascending order or in descending order. So when you are asked to do arrange an array in an ascending order, you see that how do I remember this way? So ascending means you are coming from lower to smaller number to greater number. So how do I remember that? This is A. When you type in A, the upper part is A. Okay. So the lower part is Y. So remember that way. So then ascending order you have to go from 1 to 4. Okay. And descending is definitely opposite order, right? Descending order is opposite order. Okay, higher to lower. Just remember one order correctly, then you will remember another one. So then we discussed last time bubble sort, right? Okay. So in your test, you may be given some element, an array, and you will be asked to do. If you are asked to do a bubble sort, for instance, if you are given an array of 4821, for instance, 4821. So this is the list, right? When you make this list as an array, just consider that we have just imagine that. Okay. Okay. The concept of a bubble sort is that. Okay. So then if you have how many? What is n here? Can you tell me? A number of elements. No. Oh. How many elements I have? 1, 2, 3, 4. This is my n. Okay? And then if it is n, then in the first iteration I need to do n minus 1 iteration total. Total I need to do n minus 1 iteration. Total. So in the first iteration, what it will do? It will make 4, 8, and it will create a bubble. But remember the process, I remember this way, that this is a bubble, right? This is a bubble. This is a bubble. For instance, this is a bubble. Have you already seen that? Can you see from here? Okay, so that if this is a bubble, right? So just forget about this upper part, and then consider only what is it called? This is the circumference. This is the circumference of the bubble. Okay, and consider that we will make a bubble, and in a bubble we have two edges, right? This edge and alternative edges. Okay, so we only consider only the point at this edge and this edge. So the bubble, we will make a bubble, and then we will consider this one, and we will compare 4 and 8. So then is okay. So let us make it an ascending order. Let us start to make it an ascending order, right? So then we will compare 4 and 8. Okay, so ascending order we need to 4 to be fast, right? So we don't need any extend swap at this point, right? Okay, but then we will make our bubble in the second phase 4, 8, and then 2, and then we will make our bubble a larger bubble. Okay, And we will compare only these two elements, 4 and 2, not within the element within the bubble. Okay, we will consider the elements at the edges of the bubble. Okay. Yeah, we will look at 4 and 2, right? So at this moment we will extend 4 with 2. So I have 4 and 2, so then I will extend here, then I will get 2 over here, 8 and 4 over here. Okay, so then now I will get another 1. I have 1 here, right? So then I will make my bubble larger, bigger, okay? Then at this point I will go my bubble here. And then I will compare 2 and 1, okay? So is 1 less than 2? Yes, right? So then at this point I will get 1 over here, and I will get 2 over here, and 8 and 4 will remain as is at this point. Okay? So at the end of first iteration, we will say this is first iteration. Okay? So in the first iteration, how many swap we have? We need maximum 4. We have how many swapping we have? We do not need a swap here, right? We do not need a swap here, but we need a swap here and we need a swap here. Swapping. So we have 2 swapping here, but maximum we could have 3 swapping. Right? Maximum we could have. So 1, 2, and 3. But we are lucky that we did not need 1 swapping. So we need here how many swapping? Actually, we had 2 swapping, but actually 3 iteration. So in bubble sort, actually people say that this is the position, this is your array position at the end of first iteration. Although we have some smaller iteration inside, actually this iteration is called swapping, not actual iteration. Okay, so we will not call that this iteration. Okay, the concept that we will tell this at my after the first iteration. Okay, so what is my position after first iteration? You see that after first iteration I will get at least one element sorted, right? Okay, this is the concept of bubble sort algorithm. So if you are given this array and if you are asked to write the state of your array after each iteration. Okay, so then your initial array was 4821, and after the first iteration, it will become 1, 8, 4. Okay, so this is after first iteration. After the first iteration. Okay. Yeah, sometimes you may be asked, you will be instead of writing pseudocode, you may be given an array, and you will be asked. Where is the copy? Yeah. Go into your feedback. You don't mind, I do that. When I feel bad, then I compliment. Okay, so this is my after first iteration. What I will here at the first iteration, I will get at least one element. Swap. Okay? Then I have to compare how many elements I have. Right? So in my second iteration, I will make my bubble. So after first iteration, I already have this. Okay? I don't need to do anything with this. Okay? Then I will increase my index 1, and then I will go to this, and then 8 and 4, and I will make my bubble smaller. Then what I will compare? 8 and 4, right? Okay? So is 8 and 4 going into copy? Okay, so let me, okay, so then I need to do 4 here and 8 here, right? And then after that I need to bring 2, right? And then what I will do, I will make my bubble larger, right? Then I will compare 2 and 4. Then do I need to swap? Yes, 2 and then 4, 8 is in place. Added, right? Okay, so then after at the end of first iteration, second iteration, I will get 1 and then 2 and then 8 and then 4. This is my after second iteration. So after second iteration, I will get how many elements swap? 2. Okay. Then I have to do another iteration. So after, so if you remember how many iterations did I need here? How many swapping I need? 2, right? 1 here, 2 bubbles, right? 2 bubbles here, 2 bubbles. 2 bubbles. And I had over there how many bubbles? 3 bubbles, right? Okay, so here I have 3 swapping. 3 swaps, and I have here 2 swaps, right? Okay.
Are you saying to swap or you can't swap?
Actually, even I do not swap. I think even I am not swapping here. I need to check for swapping, right? So it is actually some people this is why I told that there is variation. In some algorithms people say this will be an iteration, and then some people say this will be a swapping. Okay. So actually, what do I say? The checking or swapping, what do you say? Okay. Then, okay, so after this one, okay. So then, after second iteration, I will increase my index will be second, right? 2. Then I will come here and then I will make another bubble and I will compare it to 4, right? And then if needed, I will copy 4 and then 8, and then at this point, after third iteration, I have already 1 and 2 in place, and then I will get 4 in place. Okay, then or we already get 8, right? Okay, and then it is after third iteration. So how many swapping I will get? 1, right? So at 1 swap. So then how many total swapping I need? 3 plus 2 plus 1. 6, right? So at this point we will be done. So anyone has any question about bubble sort? The concept is that, just remember that we will make a small bubble and then we will make the bubble larger. Okay. So this is the bubble sort algorithm. Okay, the bubble sort algorithm is here. So it's pretty straightforward. So anyone please tell me, why do we need 10 variables here? because of the swapping, right? If we need to swap, then we will make, okay? So by looking this algorithm, okay, can anyone please tell me, so this algorithm will swap in ascending order or descending order? Will it swap in ascending order or descending order? Will it swap in ascending order or descending order? Yes. So I get from start from 1. Actually, so comparing pseudocode and program code is difficult for me because in pseudocode it says from 1 to n. Okay, and then so but we know that array most languages arrays start with index 0. Actually, pseudocode concept is started in earlier languages, like QSE that has index 1. But most of the modern languages have index 0, so this is confusing. So in the program code, let us go to the code, so it's not confusing. I'm telling you that because from starting 1 to n, okay, let us go to the program. So you see the program is Java program, it will start from 0. Here in the algorithm, it will start from 1 to n. Okay? Do not confuse because in most of the pseudocode considers that array index starting from 1. As we know, our programming languages start index from 0. Okay, so this is a unit of each of these, okay? Yeah. Okay, so this is a Java code. For index I equals to 0 to I less than length, okay? And if you have, like in the pseudocode, then it will be two-way. Two means included. N is included here. But here, so here 1 to n means 1 and 2 are included. Okay? But here, okay, but here you see, so if it is in a pseudocode, then most of the pseudocode will say equal. Most of the pseudocode will say equal over here, but program code will say less than. Pseudocode will say less than equal. The pseudocode will start I equal to 0, I equal to 1. Okay, and then for here I equal to, for integer j equals to I plus 1, that means j will be starting from the next. Okay, if aj, that means aj is less than this one, second element is less than the first element, then it is a swapping. Otherwise, it does not keep the swap. Otherwise, it will keep this swap. So now we will understand how to do swapping. So in order to do swapping, you need to use another temporary variable. So you have to input the first variable in the temporary variable, and you need to exchange the first one with the second one, and then you need to put the second one with the first. This is exchange. For instance, if I want to exchange this with my one hand, okay, so I have to, if I put the condition that I cannot go to 2 items at that. Okay? Then what I need to do, I need to use a temporary So here is my 10. Okay, I'm giving my 10 over here. Then at this point, programming and real life is my candidate. And in programming language, I have my own candidate. Okay, so then I will give this value. That in real life it says MG, but programming language, whatever value it has, it will be displayed within the value, right? Now I have my old whatever value I have here. Real life is CMG. Then I will ask him to give me that value, right? So in programming language, if I get a new value, the old value will be replaced. Whatever old value, the value will be done. That is stop. In programming, there is no way that it will throw a code and then it will be fast. There is no way. In order to copy, and you can do only copy on 2 elements at that. You cannot copy 3 elements. And in order to swap, you need to use another temporary. Okay? So this is the reason of using cell. Do you understand? Okay, so this is the Java code. Java code for bubble code is pretty similar with C# code, but people who are taking Python, okay, there is a difference here because the range method. Python, if you use range method, then it will be here. But if you can use for loop, right? Python, you can use for, right? Okay, so if you are in Python, okay, so if you are Python, then you see that this line, it is getting actually the for instance, the part of the array. Okay, so actually it should say len 10 minus 1 to 0. Actually, it is getting the whole array. Length is 4, then length minus 1 equals to 3, and then index we will get, because of the range method has 2 parts, right? Range method in Python, range method that takes 1 argument and sometimes it takes 2 arguments, right? Range method, so it is the concept it is taking 2 arguments and it is taking 1 argument. So people who are taking Python, sometimes it makes it difficult, and I saw this slide. Okay, so in this code, it's a good code, it's a complete program actually. It's a complete program. But here, in Python, in C# and Java, this is not a complete program. This is not a complete program, and this is not a complete program. This is a part of this code snippet, part of the code, right? Yeah. Only the method body, but here, in Python, I see that it's a complete program. You run it, then it will be working, right? Okay, so what is my method over here? My method name is bubble sort, right? Bubble sort over here, and then whatever is you provide in this method, it will work. Okay, so people who are taking Python, so you need to do more detailed stuff, okay? Then Java and C#. Okay, so anyone has any question about bubble sort? Yes. Yeah, good. Actually, there will be a number of sorting and testing algorithms. When you read one by one, that is fine. When you learn the number of algorithms, you sometimes miss them. Right? Sometimes you become confused what to do in bubble sort and what to do in selection sort, something. Okay? So this is the way actually I remember that way that how to do bubble sort. Actually making bubbles. Remember that? You make some bubbles and you need to we consider that A is the bubble, not inside, not outside. Right? And then your bubble is to be bigger and bigger. Okay, this is my last sorting algorithm I want to discuss. Directional sorting algorithm is very simple and it actually applies the linear search. Linear searching concept that we use in our searching algorithm that is applied here in the step 1. Okay. So how do we apply the linear search algorithm here? This is the step 1. It says find the smallest value in the list and move it into the first position in the list. So in order to find the smallest value in the list, how can I do that? We can do a linear search, right? And definitely we will not need to do a binary search because we know that binary search is used mainly used for sorted algorithm, but it may be needed if you are given a sorted list in ascending order and you are asked to make it descending order, right? So then it's that way. But here it says find the smallest value in the list. That means this algorithm is predicting to sort in the ascending order. This is why it says at the beginning it says find the smallest value. But if you are intended to do the descending order sort, right? Then what value will start? Here? The largest value, right? Not the smallest one, we will start for the largest one. This algorithm we are intended to do an ascending order. Okay, so consider the remaining unsorted part of the list and apply the same process in step 1. Actually, the step 1 we need to repeat it. So the step 3 is repeat step 2 on each unsorted sublist until the entire list is sorted. Let us see this with an example. Okay. This is simple. First of all, we need to, for instance, in this list, we want to do an ascending order sort. Okay, an ascending order sort. Okay, so then what we will find the smallest number. Smallest in this is will be high, right? So smallest will be replaced by the first element. All other elements will be unchanged. Okay. So my smallest number was in position first, second, third, fourth position, right? Okay, so this will be solved with 11. So 11 will go to 5 and at the position of 5 and 5 will come at the position of 11. And other elements 9, 17 and 12 will be added. Okay? Okay, and then after that, okay, so that we got, and by this way we will get one element sorted. Okay, we will get one element sorted, then we will we will, this is my subject from 9 to 12, this will be my subject. How can I get the subject? Just by extending increasing the index by 1, right? So we'll get our subject. Then we will compare 9, 17, 11 and 12, we will get find the lowest element. The largest element, the smallest element. What is the smallest element here? It's 9. So 9 is in place. So actually 9 is beginning, so we don't need to do it. Let's stop that. So this is after the second iteration. And after that, we will have this 17 to 12. This will be my unsorted list. And then in this unsorted list, we will find the smallest element, that is 11, and we will replace this 11 with 17. So 17 will take place of 11 and 11 will take place of 17. So we will get 3 elements per way. Okay, and the last iteration we will compare 17 and 12, and we will find the lowest element 12, and we will replace its position with the element, the first element of the 17th position. So we will get 12 at the position of 17, and 17 will go at the position of 12. So we will get 5, 9, 11, 12, and 13. Okay? This looks pretty simple. Okay? So I understand it. So if you know, so far 2 sorting algorithm. One is bubble sorting algorithm and another is selection. So which one is easier to use?
Almost easier to code, but the selection sort would be much more efficient because you're doing less swapping in the selection score.
Okay, that's a good point. Anyone has any question? Okay, initially this is about the selection service system for that, and we are finding the smallest element, right? So consider that for a small list it is fine, right? But consider that it is very big, large, right? There may be thousands or millions, right? Then we need to compare, for instance, here, just this. For instance, first time, for how many, what is the n size here? N is 5, right? Okay, so for 5, so how many we have to compare here? How many comparisons we have here? We have how many taking we need to do 5 comparisons here, right? Then after that we need to do 4 comparisons here. Then after that we need to do 3 comparisons here. 3 times. We have to solve the smallest one. So the algorithm is having large number. So that what will happen for the first element searching, in order to make in place of the first element, you need to do n times. You see, in order to do for the first iteration, you need to do n iteration, n swapping, n searching, n times, right? For the second one, you need to do n minus 1. For the third one, n minus 3. So n minus 2. N minus 2. Next one, n minus 3. And the last one with 1 comparison. Right? Then how many comparisons you need? If you sum this up, then you do 1 plus 2 plus 3 plus 4 plus dot plus n minus 1 plus n. Right? So then how many comparisons we need? You need n into n minus 1 divided by 2, right? If you add this series, then what is the sum of this series? Summation of this series equal to n into n minus 1 divided by 2, right? Anybody help me please? Can you help me? If I have a series, 1 plus 2, see, I got 1, right? previous was 2. Then in my equal size, there is 4, there is 3, there is 2, then 1. Then if I add these all together, then 1 plus 2 plus 3 plus 4 plus 5. What is my 1 plus 2? 1 plus 2 plus 3 plus 4 plus 5. Equal to 5 into 5 minus 1 divided by 2, right? 5 into 4 divided by 2. Is this one? Now, you need to get class 1, right? You need to get class 1. Then 5 plus 6, and then equal to 50. Okay, then 1 plus 2, 3, 3 plus 3, 6 plus 10, 6 plus 4, 10, 10 plus 5, 15. That's only in plus. So then my big O, my complexity will be big O of n into n plus 1 divided by 2. Okay, so equal to big O of n squared plus n divided by 2. Actually, it will be big O n squared. So for these small numbers, I don't have any problem. But think about if I have very large numbers. Okay, for instance, if my n equal to 1024. So then how many iterations I need? 1024 times this times 1024, right? 1024 times with exponent 2. So because for very large set of numbers, this will be 1. So that probability for selection sort will be d group of the square. This is the way you will learn how to find in the next class. Just before we take it up after class, we'll learn, okay? So this is a code, like for instance, this is an example. Okay, this is a selection sort algorithm. So again, as I mentioned that I equals, okay, from 0 to n. Okay, for me, just look at 1 to n, yeah. So 0 is included, then 1 will be, n will be excluded. So let me say, this is a program code for selection sort algorithm. This is C#, and this is Python. Again, for Python people, okay, this is complex. Okay, this will be complex because of the range factor. Okay, but maybe you can use for loop different ways than you can use that. But good thing that we have already okay, let's compare the bubble sort and selection sort. These algorithms are slow when run on large data set because of the large number of swaps that are done during the processing. Both of these algorithms will take a big O n square with Insertion sort is not needed for this test. Let it go. So, okay, so far, how many sorting and sorting algorithm we have discussed? Yeah. So in your test, you will get at least 2 questions, and then once you have written, you will get. You are sure that you will get 2. Okay?
That's the final.
Yes.
There be 2 questions on 2.
There will be 8 to 10 to 12 questions. Maybe. The test will be 2 hours. Okay? Maybe you will have more questions, some questions.
What day is it?
December 4th, from 3:30 to 5:30. So this is okay. December 4th. So anyone has any problem on December 4th? This is safe. In my GitHub account, I have, you see, go to my GitHub account and 1321 review on this, and then SRC, and then I have searching algorithms, and then if you go here, searching algorithms, then you see that I have binary search Java program, and I have linear search Java program. Okay, so you can see this code and you can run your program. So I like you to see this program and then run it with some sample data. And there is also sorting algorithms. So we discussed bubble sort and selection sort. Okay, I have complete program over here, so I like you to go to this program and then run it, or if you do Google search, you will get a complete program. Okay, so we have only one more class left in next class. Okay, so we will discuss whatever your problem, you have any problems. Okay, so in our next class, we will completely review from the beginning to end. So whatever question you have, so please bring to me. Okay, next class we will discuss. But if you do not have any question, then I will go through from the beginning, and then whatever I see that is important for the test, I will try to discuss. Okay, anyone has any question? Okay, remember that your test will be on December 4th at 3:30. It will start 3:30 to 5:30. Okay, the test will be 2 hour duration. Okay, people who have sleeping problem, drink coffee. Okay. Thank you so much.